Okay, today we're going to talk about the 3D printed heel toe walker assembly, how to print the parts and all that good kind of stuff. I plan on getting the files up on Thingiverse if Thingiverse is still working. Haven't checked it out yet. But we're going to start assembling a leg assembly on the heel toe walker, and when it's all together it's going to look like this. This would be a right foot. There's a right and a left, and in the rear there are two little wheels which freely spin. There's no ratchets, and in the front you do have to glue on a piece of rubber or something that can be used as traction. In this case I grabbed a piece of an old inner tube and just glued it on there, but you could take a piece of a rubber band, cut that and glue it on the bottom right up near the toe. And this will be the first part. This 3D prints sitting as it's shown in my hand. No supports, nothing left to clean up. Then, like I say, just glue on some sort of rubber gripper there. As far as the assembly goes, you've got this main leg support strut, if you will. This is the crank one because it has the hole for the crank drive to go in. And when you put this in the foot, you're going to want this large stem. This is going to be used to make the arms move later, facing towards the back, not towards the toe. And I used a welding rod because I had a bunch of it, 1/8 inch welding rod, which is about 3 millimeters. Let's check that for all you millimeter guys. This measures 3.1 millimeters and makes a good axle. I had a bunch of it, and there's holes. You have to cut a piece that would be not longer than the foot, but about as long as the foot, because you're going to need 2 axles to do this. And push it in like that, and then find something to shove on. I'm going to shove on the... This won't show up on camera. I'm just shoving on the edge of the table. Push that in all the way. So you can see the axles in there now. So this is the front, and this is facing towards the back. Now the rear one has more things going on, because you've got the 2 wheels. So here's what this looks like. I've started this shaft. The wheels, of course, print flat, no supports. They have a little nub facing up. You're going to face the nub away, trying to get it away from the side. So it's like that. Then the next thing you're going to work in there is this rear linkage, support rod if you will. And this is, there's no right or wrong, it's symmetrical. So you're just going to take and work it up. Get it to where the axle starts. So now we're at this point. See where the axle is and the 2 legs. We have one more wheel to put in over here. And again, the nub on the wheel faces away from the outside of the foot. Just line it up till it hits the axle. And I think I can push this one in with my fingers. So there we go. You have that on there, that on there. And your assembly should look like that if you're making the left foot. See? Here is the right foot. Curvatures will go to the outside when you assemble the robot. Flat sides towards the inside. So the next thing you're going to want to print is going to be the motor frame. Now this isn't the finalized version of the frame. It's here. But I'm going to start with this one so you can see what it looks like when there's nothing in it at all. There's a place provided where you can glue a single AA battery holder in there. There will be a rod that passes all the way through it like that. So you need to maybe insert the rod when you glue that battery box in there so that you don't go too low, but you want it as low as you can go. There's a slot here for putting in a slide switch if you want to use it. I'll dig one out here so you can see what it is that I typically use on all my projects. Here we go. This is a double pull, double throw little slide switch. You can find them everywhere. eBay, AliExpress, probably Amazon. I normally bend the two links to each other, solder them, because we're going to be putting wires on there for the on-off. It's about 19.2 millimeters mounting hole to mounting hole. These are generally already threaded for a number 2 machine screw. In any event, what I was trying to get at is the switch will go in above and then just drop straight down. Then your screws will go through these holes and screw into the switch to hold it in place should you decide to use the switch. Okay, I'm going to put that switch away before I lose it. Oh, the TT motor I'm using is the high-speed one, the most common one, the 48:1 gear ratio. And when you drop it into the frame, it literally will just drop straight down like that. And there'll be places where you can put in, here in America, it's a number 632 screw. It's the screw that would be used, for example, in our AC power receptacles. Of course, you can get a 632 screw anywhere, but I'm just saying, if you've got an old receptacle laying in the garbage, or maybe you've got an AC plug that's sloppy and loose and you need to replace it, go ahead and replace it and then save those screws. Also the same screws that are in a wall switch, toggle on-off switch. That's what I'm using, and that's what I set the holes up for, and they thread right into the motor. So let's get that set aside. So here we have the unit as it finally gets printed. Like I say, there was a few differences. The switch is mounted, the battery holder is mounted. In this case, I took the black wire from the battery and soldered it to one terminal of the switch. Took another wire from the switch and just ran it up the side, glued all that in place. Here's the motor. Here's where we're going to be putting the 2 screws to hold this side on. There's a piece that we screw on with the same 2 screws. It's a hip, and it looks like this, and it prints flat as well, and it literally just sits right on there. And then you take your screw and I need a screwdriver. Start that one and put this one in. And just screw the hip down. That'll hold the motor in place and hold the hip pivot joint in place. Next thing you've got is this cam. As you can see, it has a D slot in it already to match with the motor D slots. This side, you can see I already have the cam pushed on. That one's facing down, so when we put this one on, we'll want it facing up. You want your 2 cams to be opposite each other, so that when they rotate, they have an opposite effect, like so. The 2 wires, getting back to the wiring before we get too far, the top of the battery had 1 red wire. I brought it over to the motor. Then, like I say, that extra wire that I brought up from the switch, brought it over and soldered it to the motor. That gave the motor power. I plan on putting lights, LEDs actually, and a power booster up in the head of the robot. So I just tapped off that same 2 points and leaving this as a pigtail for going up to the head. So that's all that's going on there. Real simple wiring. Okay, next you've got your leg assemblies. Like I say, this, get it so the camera's seeing stuff. See how that just fits on like that? This is going to be held in place by the body so it can't come off, and there's going to be that rod that we talked about earlier that's going to hold the rear one in place. So your 2 assemblies sitting on there at this point, just by hand, is going to look like this. And there's nothing holding these rear ones at the moment. We're going to fix that in just a second. If you want to visualize what I'm talking about without the body on there, here's a rod passing it through the hole in the body, passing it through there. So now you can see everything is shimmed together. In fact, everything should pretty much work at this point. Like that. And you can see the action that's happening there. In this type of mechanism, the rear wheels on both feet always stay in contact with the tabletop, and the foot that's moving forward lifts the toe up in the air, and then when it's time to take the step, it drops the toe down so that rubber grip will make traction, and that's what pulls the body forward for the next step to happen on the other side. There's nothing holding it together until we put the body on there. Okay, so let's start talking about the body. The body prints as one piece on your printer upside down like this. No supports required. It's open in the back. And then you're going to want to print this arm lever. And again, it prints flat, no supports. And you're going to want to print an arm. And again, it prints flat, no supports. And to put the arm on, you can see I already have the arm on this side. You just take this support part and you go in from the inside, so it's poking through. Take the arm, put it right on that shaft, and I'm using a tapping number 2 screw because there's a hole provided to tighten things up. Just get them snug and adjust the arm so it's just about where this rounded part is just protruding past the front. If you didn't have screws, you could of course glue this part. Basically what's happening is the little lever on the inside, see that lever move? It goes all the way up to the top and it can't go any further. So when it's all the way up to the top, if you have your arms set at about that position, that's going to work out pretty good. So this whole body, we're going to do this upside down so that the arms levers stay in a safe position. This whole body basically just slips over this assembly that we made here, but we can't have this rear rod in when we do this. So let's take the rod out. We're going to take this whole thing upside down. We're going to feed it into the body, just like so. Then we're going to start aligning everything up with this rod. We're going to start by sighting that hole in that rear pivot in the side of the body, and then that should drive right through into the gearbox like that. It's going to go through the gearbox if we're lucky. And now we got to line up this side. The easiest way is just to sight it through the hole in the body. It's going to get you close, like so. And again, I'm going to use a table to push the pin in place, like that. Now I haven't made, but I was thinking about maybe making some little caps that could be glued on either side of that pin, just for cosmetics. The pin isn't going to move on its own. The arm should now have dropped down, and the wire, I was wondering what was hanging that arm up. The wire that I'm going to be running up to the head is stuck in there. There we go. So at this point, if you run the toy, you should have the leg actions and the arm should be moving. Like so. Alright. Now the head prints upside down, no supports, one piece. The little red dome, of course, is a separate piece. There's a 3mm hole in the top of the head, so if you have a 3mm LED, I'm using a flashing LED for the top, so it's up in there. Then in the front I had these very odd shaped square LEDs that kind of a yellow-red, a yellow-white color when they're on. They were from some yard lights I think I got from the dollar store or something. But that's a 5mm hole, so you could take any standard 5mm LED and push it in from the inside. So that's what I shoved in there. And to boost the 1.5 volts up, I'm using, you can buy any sort of little voltage regulator booster you want. But I found these dirt cheap on eBay. And I just basically take the nippers and cut the USB port off. So you have a V plus in and ground. That's coming from our wires from the motor and the robot. And then over here you'll have your 5 volt and ground out, which you can run up to your LEDs. And of course I'm using current limiting resistors on the LEDs. I'm using 330 ohm because I want to keep the current level low, since everything is pulling off that one battery. And also because I don't need these to be super bright like a flashlight. I just want them as an indicator. I just want them lit. And so the plan is to solder the wires into that head part up in there, and then the head should be able to be glued right down onto the body like that. Now, I haven't tried this yet, so I don't know whether I can solder those wires in on camera, or whether that's going to be something I have to do in a separate video. But I'm going to give it a try. I think it'd be easier if I was off camera and the whole thing was laying down on the tabletop. But I'll try and do some of it up here. The two LEDs are in parallel with each other, so there's only one 330 ohm resistor for the two of them. Of course, you know, LEDs have a polarity. They have a negative and they have a positive. Anode and a cathode. I think I got that wire on. Okay. I think that'll be okay. Then my plan was to stuff the wires up in the head so that they wouldn't get entangled into the arm linkage stuff. Like so. And when we hit the power, oh, okay, we got eye lights and we got blinking light on top. Now the head isn't glued down, obviously, but if it were glued down, looks like everything would be working. Typically I would want to glue that down with something that's removable, so I probably would use E6000, which is kind of rubbery, rather than a permanent glue. One thing we didn't talk about is I have some more of these small tapping number 2 screws, and on the side of the robot there is still a hole right here, and this basically will join the body to that hip point, that pivot point. So now the body is held in place not only by this pin in the back, sitting flush against the motor mount in the front, but also a screw on both sides, which the arms typically would be over the top of, so you wouldn't even see the screw. Not that there's anything wrong with seeing a screw. Like so. A faster glue though, if a person's in a hurry. And I've covered this in other videos, so you can look it up. But it's your number 16. And this tube may be plugged up because it's been a long time since I've used it. So let's see if I got something I can poke around in here with. But I think if it doesn't all come gushing out, I think if I work a little of this around the neck, and hopefully I won't need to take this thing apart, this shit's fairly permanent. Okay. Trying to sight if I've got it aiming semi-forward. unlike super glue, which is just a surface glue, but this stuff actually melts and eats into the filament, PLA. So it's a much stronger bond. It's much more permanent. Super glue you can almost always crack loose, and in fact will generally break loose in a year or two, because the plastic will contract and expand with the heat in the room or the temperature changes, but the super glue won't, so it fractures because it's so brittle and because it was just a surface glue. Whereas this stuff is actually melting the two parts together so that it's fairly permanent. Okay, let's change camera angles and see if we can get it where you can see the action better. Kind of wish the camera were lower. It's not, so I'm sorry. Okay, I think that is mostly on screen. But you can see it has a real nice foot lifting action. So that's your heel-toe walking robot, 3D printed. This surface isn't real smooth, but you can get the idea. Oh, I'll try to get the files up on Thingiverse for any of you that want to build it.